this video, we're going to be talking about variables and data types in Go. So open up your favorite IDE or text editor and let's create a new project. For this tutorial, I'm going to be using GoLang, the JetBrains IDE for Go, and I'm going to do a new project, and it's just putting it in my users scriptster go/src/awesome project, and we'll call this variables. And let's create our project. So let's go and do a new Go file. And remember in the previous video, we can name this anything we want, but the standard for most executable Go programs is main.go. So I'm going to use main.go. All right. And let's zoom in on this. Cool. So the GoLang IDE automatically added this package variables to the top of my main.go file. But since we're creating an executable file, we learned in the previous video, whenever we're creating an executable, we need the package to be main, and we need func main for the Go compiler to know that this is going to be an executable file. We also learned how to import. So let's go ahead and import, and we're going to bring in the FMT package. And let's define it down here. So we'll do FMT. We're going to use print ln again to print some data out to the terminal. And that should be good. Now in the previous video, we didn't talk about comments or adding notes inside of our code. If you're coming from another language, this might sound redundant, but if you're new to programming or you're coming from a language, maybe they did commenting differently. I just wanted to go over this real quick. To put an inline comment in your code, you can use the // and then type some text. So I'm going to type string because we're going to be learning about string variables. Now, if you're new to programming and you've never worked with variables before, it probably sounds a little scarier than it really is. If you've done algebra level math in your life, you've probably seen something like x plus 2 equals 4. Well, in this scenario, x is our variable. We can define x and we can say x equals 2. So by defining x, then x plus 2 equals 4. Let's go ahead and define some string variables. So in order to let the Go compiler know that this is going to be a variable, we can prefix with var, V-A-R. All right. And then provide a name for the variable. In this instance, I'm just going to use a. And then we need to let the Go compiler know what type of data is this variable going to store. For this, we're going to use string because we're learning about string variables. So let's define that this is going to be a string. So now we have this variable a, and it holds a string. All data types in Go have a default. Now we haven't actually said what the variable a, we haven't provided it a value. So let's just see if we print ln and then a, for the variable a. Let's open up our terminal and zoom way in, and let's do go run main.go. All right, so we didn't get an error, and it just produced this blank line. It definitely skipped a line, so it printed something, but we never provided the variable a string. So how do we provide it a string? We can just say equals, and then in double quotes, whatever we want our string to be equal to. So for this, I'm just going to say hello world. The GoLang IDE automatically saves whenever I'm typing, so I don't actually have to go and Command S to save or file save or anything like that. So if you see me going right from the text editor up here down to the IDE without acknowledging that it's being saved, it's the GoLang IDE is doing it for me. So we have var a string equals hello world. So if we run that same command again, instead of getting a blank line, we should see hello world. So let's see. Pretty cool. So we can use var a to define a string, and we can set that string equal to something. If we don't set it equal to something, it's just going to print a blank line. What if we did, let's get rid of world and do var b. We're going to say var b as a string, and we'll say var b is equal to world. All right. So let's add b to this print ln and run it again. Hello world. So I didn't actually provide the space between hello and world up here. I didn't put a space right here, but you can see the Go compiler when it uses the FMT package and println, it automatically adds a space between the first variable and the second variable. So that's good to know. Now this list of variables could get pretty long. We could A, B, C, D, E, F, G, go through the whole alphabet, and then we have this real long list on our screen. In Go, they actually have a way when defining variables of the same data type, so right here we have of type string, we can actually define them all on the same line. So we can say var A, comma B, and comma C, and then they're all of type string, equal to, and then this first string right here, comma, world, and then comma, and then your last string. So hello world all. Instead of typing var, string, 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 string on a bunch of lines down here, we can put them all in the same line right here. So let's see how that works. So we already defined in our FMT println A, B, and let's do C, and let's run this again. All right, so we can see we printed A, B, and C. Now, right now, we're providing our variables outside of our function up here. So we're doing it outside of these curly braces right here. When we define them out here, this is actually considered a variable at the package level. We also have the ability to provide a function level variable down here inside of func main. So we could do var d and tell our compiler that that's going to be a string and set that equal to another value. So let's do everyone. Now you'll see we're getting the little squiggly mark here under the D, and that's because we haven't used this D variable. If you declare a variable, you have to use it. Otherwise, just go ahead, highlight, and delete. But we want to test this out, so let's go ahead and put D after C. And you'll see the squiggly marks went away because we're using the D variable. So let's run this again. Go run main.go. Cool. Hello world all, which we defined up here as a package level. And we're using these variables inside of a function. So if you have variables that you're going to use in multiple functions, we didn't go over functions yet, but you can have more than one. We would define a func and call it something else and put it down here. And this other function down here could use these variables. So if you need your functions to essentially share variables, you can define it at the package level. If the variable is only specific to the function, you can define it at the function level. Now, one of the cool things in Go, when you define a function level variable, we can actually use the short assignment operator. Now, you're probably asking yourself, what's the short assignment operator? Well, it allows us to get rid of this var right here. We can get rid of string, and we can put a colon before the equals. So D colon equals everyone. And what they say is, to use this short assignment operator, you must have implicit type. So by providing the double quotes, that lets the compiler know that this is going to be a string. If we were to remove the quotes, unresolved reference, it's not implicit, it's not obvious that this is a string. So D colon equals everyone. Let's run this again and see if we get the same result. Cool. Now, if you're wondering what happens if we put this outside of the function, and we'll just put it up here, you can already see I'm getting a little squiggly, D unexpected, because we're using this short assignment operator. Now, we're only really able to use it down here inside the function, but just for fun, let's see what happens. We get a syntax error, no declaration statement outside of function body. So as we can see, this needs to be inside of our function. Let's run it again just to make sure that it's still working. Cool. So as we can see, package level variables, we have to use the var, we have to specify the type of data or the data type, but at the function level, we can use this short assignment operator. Pretty cool. So let's move on. I'm going to clear this out and we're going to talk about integers. So again, I'm going to use the comment, the // and type integer. All right. And let's go ahead and clear this out as well. Cool. All right. So let's talk about integers. Integers are whole numbers, no decimals. And in Go, we have two types of integers. So I'm going to say signed integer, and let's put another comment and we'll say unsigned integer. All right. So we have two types. So let's go ahead and create our var, our variable. We'll call this A. And in order to let the Go compiler know that this variable is an integer, we can just say int. For an unsigned integer, let's do var b, and you can put u for unsigned int. All right. Let's just go ahead and print out A and B. We haven't actually provided a value for our int. So let's see what the default is. Go run main.go. All right, so we can see the default for both signed and unsigned is 0. Now, you're probably asking yourself, well, what's the difference? A signed integer can be both positive and negative. So a positive number and a negative number. I'm just going to put a little note up here that does plus or minus. An unsigned integer only does positive numbers. Let's go ahead and test this out. Let's supply some values for our int. So we'll say int, our variable a int is equal to 1, and our variable b int is equal to 2. All right, and we're printing it out, and go run main.go. So we have 1, 2. Now, I said a moment ago that an unsigned integer can only be a positive number. So let's make this -2. All right, and then let's run this again and see what happens. So it's giving me this error that it can't compile because I specified that this is an unsigned integer. Variable b is an unsigned integer. Under no circumstances will there ever be a negative value. So it won't compile and you get this error. So we've done a positive integer for a signed int, but we haven't done negative. And up here, we're anticipating it can do positive and negative. So let's run this again. All right, so we can do positive and negative when we specify int, and we can only do positive when we do unsigned or uint. Now, the way I like to think of this, to make it easier, u or up. I always like to think up from 0. So uint is the same as up or above 0. And then int can be above or below 0. So we also have a few other types of int. And if I type var c int, you'll see it pre-populates for me. We have int 8, int 16, int 32, and int 64. I'm just going to click on this int 8 to do an example. And I'm going to set this int 8. We know that it can hold a positive or negative number. So let's just give it a value of 10. And we have the exact same uint 8. So let's go ahead and do var d, and we'll say uint 8. And we'll set this equal to, and it has to be above or equal to 0. So we'll set this to 20. All right. And let's print C and D. All right, so go run main.go. Now we printed our -1 for variable A, 2 for variable B, 10 for variable C, and then 20 for variable D. Now, you're probably asking yourself, why would I use uint 8 or int 8? And the reason for that is we're actually specifying the amount of space we anticipate the number to take up in memory. Now that might sound confusing. How much space is allotted or provided for an int 8? What is our limit? We just set a limit we said it's 8, but what does that actually mean? So an unsigned integer can be a positive or negative number. By providing int 8, we're letting the compiler know that under no circumstances is this int 8 ever going to be less than negative 128 or greater than 127. So we've just set a limit for ourselves. We basically told the system, give me some space. I promise the number I put in the space that you save for me is never going to be lower than negative 128 or higher than 127. So let's go ahead and provide, we'll just do 130. All right, so we've told the system we're only going to use negative 128 up to 127, but we just provided 130. So let's see what the system does, because we just lied to it. We're using a number larger than we've anticipated. So go run main.go. Constant 130 overflows int 8. So the system's saying, hey, you told me it was only going to be this big, and this is way bigger than I anticipated. I don't have room for this number. Now, without going down the rabbit hole of how data is represented and stored in computer memory, think of this as a glass of water, right? You said this glass of water is you're only ever going to put 8 ounces in this glass of water, but you just put 9 ounces. You said 130 is actually 9 ounces of water. The system says, hey, this glass of water is going to overflow if you try and pour extra in here. So we've reserved 8 ounces, but you're giving me 9. Like, I can't let you do that. We also have a few other ints, as we saw. So if we do var e int, we'll do 16, and we'll leave a comment there. We have var f int, we have 32, and we're going to do a comment in a second. And we have var g, and we'll do 64. With each of these, we're letting the system know I'm never going to provide a number bigger than the amount of space that you saved for me. So if we're thinking about this like before, this is 8 ounces of water, this is 16 ounces of water, this is 32 ounces of water. The system basically set aside enough space to only hold exactly 16 ounces of water. Now, this obviously isn't water, this is memory we're talking about. How much space do I actually get with int 16? It's obviously going to be bigger than negative 128 or positive 127, but how much space do I get? With an int 16, we know it's signed, it's 16-bit, and this can hold an integer as low as negative 32,768 all the way up to positive 32,767. Let's see what int 32 can do. So int 32 can do, we know it's a signed integer, it's 32 because we specified 32, and that's 32 bits, and it's an integer, and it can do a number as low as this and as high as this. We're doing almost 1 billion, I guess, if we put commas and we say an integer as high as 2,147,483,647. That's a pretty big number, and it goes negative as well. So we've told our system by specifying int 32 that our number, we promise our number isn't going to be smaller or bigger than this. All right, and let's see what int 64 does. Now, if you haven't guessed, int 64 is going to be the biggest. So let's go ahead and see this. I'm not even going to try and say that number, but we can go negative this many or positive this many. All right. We have the same exact options when we do unsigned integers. So we have uint 8, and let's see, let's do var h, and we'll say uint of 16, and I'm just going to put comments here, and we're just going to list out the size that these numbers can be. Var I uint, we'll do 32. All right, and then var j uint, and we'll do 64. Now remember, an unsigned integer, a uint, is up, I should say above or equal to 0. All right, and let's see what uint8, we know it has to be above or equal to 0, and since we're not having any negative numbers like a regular signed integer, let's see what that can go up to. Any guesses? So it's uint8, which is an 8-bit integer. So our int8 is actually an 8-bit integer as well, but it does positive and negative numbers. If we were to find the difference between these two numbers, it's actually the same as these two numbers. The reason this goes up to 255 instead of 127 is because we're only doing positive integers. So this number starts at 0 and goes up to 255. Let's see what 16 does. So 16 is going to occupy the same amount of space in memory because it's going to be, if you didn't guess, a 16-bit integer, but it's an unsigned integer. So we know it's only going to be a positive number. So an unsigned 16-bit integer can hold a number between 0 all the way up to 65,535. All right, now let's check out uint32 and uint64. All right, so uint32, it's an unsigned 32-bit integer, and it does 0 to this really big number. I'm going to stop trying to say these out loud. And let's see what uint64 is. So uint64 is an unsigned 64-bit integer from 0 to this insanely large number. Now this is an intro to Go, so I don't want you guys to get hung up on uint8 and uint16 and int64. We're going to be sticking with the int for the most part in most of our videos. When you get to more advanced things like timestamps in Unix, you're probably going to use an int64. Timestamps stored in Unix are actually, it's just a number. It doesn't actually say January 2 of 1963 at this specific hour and this specific number. It's actually just a straight number, I believe in milliseconds, from a specific date. You would use an int64 to represent that timestamp, but we're not going to dive into all that. We're going to stick with our regular int and maybe our uint for now, but I wanted you guys to see that you have the ability, if you know without a shadow of a doubt that your number is going to be within a certain amount, you can specify and let the system know, don't even allow a number bigger than this, and it'll obviously give you an error. So this is just a brief introduction to integers. If you want to go ahead, you can play around with these, but for the most part in this getting started with Go, I'm going to try and hang around these ints and uints, and then maybe in some more advanced topics, we'll jump into these uint8 or int64. I think it's important for you to know that these data types are available to you, but they're used for some more advanced topics that we'll get into later on down the road. So let's go ahead, and I want to get rid of all this. All right, and we're going to move on to the next topic, which is floats. So let's talk about floats. First, let me clear this out. All right, and like we did before, let's add a little comment, and we're going to call this floats. And what do we need to know about floats? So similar to ints, floats have 32-bit and 64-bit floating point numbers. So let's do 32-bit float. All right, and let's do 64-bit float. Okay, now if you haven't guessed from our previous review of integers, we can do var a and then float 32. All right, and let's do a b as well. So we'll do var b float, and this time we'll do 64. So we're not going to provide a value. Let's just see what a and b print out on our screen. So let's do go run main.go. Cool. So by default, a float 32 and a float 64 both default to 0. Based on our previous example with integers, a float 32 is going to be 32 bits, and a float 64 is going to be 64 bits. So a float 32 is going to tell the computer, hey, save me 32 bits of space in memory, and a float 64 is going to say, hey, save me 64 bits of space in memory. So a float 64 can hold a larger number or a larger value than a float 32. So let's just test this out, and we'll say float 32, and we'll do 12.865, okay? And for a float 64, we'll do 1,234.54. All right, and let's print this out to the screen. Cool. So we could see we were able to store numbers in both and print them out to the screen. So if you need to store a really large decimal point, you're probably going to want to use the float 64. If you're storing a smaller decimal point, maybe you're just doing money, you can probably get away with a float 32. I'm going to leave it there for floats. We'll probably end up diving in deeper as use cases arise where we need the float 64 or a float 32, but I just wanted to bring it up so you guys can kind of get a feel for what these mean. So a float does decimal points, and 32 is the amount of bits in memory that we're telling the system we need to store that decimal point. All right, so let's go ahead and clean this up again. I'm going to get rid of that, and let's get rid of our A and B. And for this last segment, I want to talk, or I want to at least bring up complex numbers. So let's go ahead and we'll do complex, and let's talk about complex numbers. We'll clear this out. And what do we need to know about complex numbers? If you're using complex numbers, I want you guys to know that there are two options when it comes to complex numbers. We're going to do var A, and we'll do complex 64, and we'll do var B, complex 128. All right, and just like before, let's print these out, A and B, and we'll do go run main.go. Now, as you can see, this is the default for a complex 64 and a complex 128. I wanted to show you guys that complex 64 and complex 128 are data types in Go, but if you're watching this tutorial, you're light years away from using either of these. This gets into some real nitty-gritty mathematics and uses built-in functions and imaginary and real numbers, and it's just way too advanced for an entry-level Go variables tutorial. I want you to know that it exists, but maybe in a year from now, or who knows, maybe in 6 months from now, you're up and running with this and you're like, hey, I want to jump in with those complex data types. Maybe we'll do an example in the future, a real-world scenario where we need to use these. But for an entry-level Go tutorial on variables and data types, we're getting in a little over our heads with these. I think it's important to understand the difference between a signed integer, so positive and negatives, and an unsigned integer, so U for up. I always think up or above 0. Keep that in the back of your head as you're working with this. I'm sure there's going to be scenarios that come up, and we're probably going to be using those throughout the duration of these tutorials and examples, but I think these complex numbers are a little above my pay grade. I hope you learned something. Go ahead, like, subscribe, hit the little bell icon so you get notifications, and I'll see you in the next video.